Okay, everybody. We're gonna learn about color. We're gonna learn how we see colors like red, orange, yellow, green, blue, and purple. We're gonna look at our test book for all the answers we need. What? It's broken? That's okay. I can show you all the information you need through this video. Okay, let's start learning about color. Okay. First, light is emitted from some object. Then that light is absorbed by some other object. But not all of it. The object reflects a specific wavelength of light back. When that light enters the eye, we perceive it as color. Now that's great, but how are we able to distinguish different colors? How can we tell the differences between the reds and the greens? The yellows and the purples? And the oranges and the blues? Well, that's what two physicists, Thomas Young and Hermann von Helmholtz, found out. You see, they already knew that any color can be created by combining the three colors, red, green, and blue. Through a process called additive color mixing. This is where you take the three primary additive colors, red, green, and blue, and combine them to make several different colors. Red and green make yellow. Blue and green make cyan. And blue and red make magenta. Combine all colors, you get white, the combination of all colors. So Young and Helmholtz inferred that our eyes have receptors that are sensitive to those colors, red, green, and blue. With years of research, they were able to come up with the Young-Helmholtz trichromatic theory, which proves that the retina has those receptors. When we see red and green light, we see yellow. When we see green and blue light, we see cyan. And when we see red and blue light, we see magenta. And combine all those three colors together, we see white. And with different shades of those colors combined, we can see several other colors. But wait, that color theory didn't explain everything. Like colorblind people who can't see red or green but are able to still see yellow. That is what physiologist Ewald Hering pointed out. He was able to figure it out through after images. If you were to stare at a certain color long enough, then stare at a white piece of paper, you would see its opponent color. Red is the opponent color of green. Black is the opponent color of white. And yellow is the opponent color of blue. A century later, researchers were able to confirm Hering's opponent process theory. Nerve cells in the retina and the thalamus are on some colors, but are off on their opponent colors. If you detected one of those colors on a specific point of the retina, you cannot detect its opponent color on the same spot of the retina. So if you stared at green for a long period of time, then looked at a white piece of paper, you would only be able to see red, because the red receptors are firing normally at that time. Well, I did it. I told you all I know about color in this video. Well, that's it. Bye!